So today let's see the continuation of the next topic, that is of Basic Electronics Module 1, which was Power Supply. The subject code is 21 ELN 24. Okay. So in the last video we have seen the introduction of power supply, what are the different blocks of power supply. So today we are going to learn about rectifiers. Okay. So what is meant by a rectifier? Rectifier, as we have mentioned in the previous video, rectifier are the device which converts AC signal to DC signal. So it can be also called as AC to DC converter. Basically there are two types of rectifiers. One is called as the half wave rectifier and another one is called as the full wave rectifier. So full wave rectifier can again be divided into two types. One is your biphase rectifier and the next one is your bridge rectifier. So basically what is the difference between these three rectifiers is that in half wave rectifier we utilize one diode, a single diode. Full wave rectifier, under full wave biphase we use two diodes, and under bridge rectifier we use four different diodes. Okay. So moving on to, this is the overall introduction. Okay. So in half wave rectifier, so this is the diagram of a half wave rectifier where we have, this will be your first stage, that is the transformer, right? So what type of transformer? It is a step down transformer. So the first part is your step down transformer. So half wave rectifier we use only a single diode. This is your resistor R, okay, load resistor RL. So here we use a single diode. Then, so half wave rectifier means what is the input and what is the output. Input will be a sinusoidal signal, right? So this is your input signal which is given. Half wave signifies that the diode conducts only in one half cycle, that is only during the positive half cycle. So you will be getting a wave, output wave only in positive half cycle. So see, during this see, if I take this as 0, time t1, time t2, time t3, etc. Time 0 to t1 you will be getting the output. T1 to T2 during the negative half cycle you do not have any output, so no output here. Okay. Again time T2 to T3 you are getting an output. So what is meant by, so this is your half wave rectifier. In full wave rectifier you have two types, biphase rectifier. In case of biphase rectifier you will be utilizing the transformer which is center tapped transformer. Okay. So it is divided into two. So here it is step down transformer. Step down transformer. So in this case you use two diodes, diode D1 and D2. So what will be the signal? Input mains signal is 240 volt. It is divided. So if I take three nodes A, B, C, right, the potential across here you will be getting a potential, here potential. Okay. So the voltage VAB can be given as 12 volt and VBC will be again 12 volt, right? So this is the only difference and with the diode, two diodes D1 and D2. So in full wave means the entire full wave you will be getting the output. During the positive half cycle as well as in the negative half cycle you will be getting the output. See here, if I take this again as 0, T1, T2, T3, T4. So 0 to T1 you will be getting the output. Similarly T1 to T2 you are getting the output. T2 to T3 you are getting the output. So it is converted, the AC signal is converted into DC signal, right, with ripples. So here it is the negative half cycle. Also you will be getting the output where your signal will be in the positive half cycle, right? So this is your biphase rectifier. Next one is your bridge rectifier. So what is meant by bridge rectifier? So bridge rectifier is a rectifier where you will be utilizing four diodes and it operates in full wave, right? In both the half cycle you will be getting the output. The difference between biphase and bridge rectifier is that here the center tap transformer is being avoided. That is the difference. Okay. So this will be your first stage, step down transformer. So what step down transformer, here you will be using four diodes D1, D2. So why did I take this as opposite D1, D2, D3, D4? The reason is that the opposite two diodes conduct at a time. That's why I have taken it as D1, D2 opposite side, D3, D4 opposite side. So during one cycle D1, D2 will conduct, during the other cycle D3, D4 will conduct. So what about the output? The output will be same as that of your biphase rectifier. That is, during both the half cycle you will be getting the output, right? During positive half cycle 0, T1, T2, T3, T4. So during all the half cycle, during positive half cycle also you will be getting the output, during negative half cycle also you will be getting the output. Okay, so these are just the introduction of a rectifier. Now we will be seeing each rectifier in detail. How is it working? Okay, so now let us see the half wave rectifier in detail. So half wave rectifier, okay, rectifier in detail. So let me draw the diagram once again. The same diagram I am going to draw it once again. Okay, so your main diagram will be equal to, this is going to be your main diagram which I have shown previously, right? You will be having a transformer. So the primary voltage will be equal to 240 volt, right? Now you are going to use only a single diode and you are going to use a resistor RL. This will be your ground. Okay, so what will be the voltage here? The voltage here will be equal to 12 volt. This will be your diode D1, right? So this is going to be your major diagram of your half wave rectifier. So what is the use of this diode? So you know that a diode, if this is a diode has two terminals. One is your anode and the other one will be your cathode, right? Anode positive and cathode will be negative, positive and negative. So the diode will be acting as a switch, okay? During the forward bias condition, it will act as a closed switch, okay? It will act as a closed switch. During the reverse bias condition, so this is your forward bias condition. During the reverse bias condition, your diode will be acting as an open switch, right? You know this concept, basic concept. So it will be acting as an open switch. So based on this basic concept, we are going to reconfigure your diagram, right? So I can take it two cases now, okay? So your input, you know that the input is your sinusoidal signal. So V in, this is your sinusoidal signal. So if I can draw the waveform, so I am going to draw a waveform here, okay? So let me take another color. So if this is your waveform, V in, right? V in, you know that it is a sinusoidal waveform. Time period, okay? Now we have to plot the V out waveform also. So you will be having two cases, during the positive half cycle and during the negative half cycle. So if I take this as V naught, okay, V out across the load resistor RL, okay, for example, across the load resistor RL, you are getting V out. Now we are going to plot what will be your waveform. In the first video we have seen right, this is your waveform. During positive half cycle you will get the output, during negative half cycle there is no output, right? So we can take two cases now. Case 1. So what is your case 1? If I take this as 0, T1, T2, T3, T4. If I take the time period 0 to T1, or I can tell that during positive half cycle, right? During positive half cycle. So during positive half cycle of the input signal, this is going to be your first condition during positive half cycle. So what will happen to your diagram now? What will happen to your circuit? The circuit diagram will be reconfigured into, so this will be, input will be equal to 240 volt, right? So your output you will be getting of the secondary, you will be getting it as 12 volt. Now what will happen to your diode? During, let me give the option of a switch. Now this will be your RL, right? Now what will happen to your diode? Now during the positive half cycle, what happens to your signal? Here it is positive, right? Here also it is positive. So when positive and positive, if I am giving an input positive to the diode, what will happen? Positive and positive, it will be forward biased. So forward bias means positive and positive. If you have positive and positive, it will be forward biased. If you have negative and positive, then it will be reverse biased. So in this case, your input is positive. So your diode also, here it is anode. So it will be forward biased. It will act as a closed switch. Okay, it will act as a closed switch. Now how will be your current conduction? This will be the current will flow. This will be your current conduction. So done. So during the positive half cycle, you will be getting the output. Whatever is the output, whatever is the input, you will be getting the output. I'll come on to the peak values. We'll see it by means of an equation. Okay. So understood this concept? I'm repeating it once again. During the positive half cycle, the diode will be positive will be forward biased. It will act as a closed switch and it will the current will flow. Okay. So this will be your V out. You are getting the signal. So case 2, what will be your case 2? T1 to T2. T1 to T2. That is during negative half cycle or during negative half cycle. During negative half cycle, what will be your circuit? During negative half cycle, your circuit will look like, right? So your diode will act as an open switch. 240 volt transistor T1. Here the voltage is going to be 12 volt, right? Now let me give an option here. So this is going to be your circuit RL. So now what happens here? During negative voltage, this becomes negative, positive. So negative and positive, it becomes, here it is negative, incoming signal is negative. But your diode here, previously it is anode. So negative and positive, it is reverse bias. So your diode will act as an open switch. There is no current flow. Okay. There is no current flow or there is no conduction. So it will act as an off state. There is no signal here. So during positive half cycle, you will be getting the signal. During negative half cycle, you don't have a signal. That's why it's called as half wave rectification. Only during the half duration it rectifies. Okay. Similarly, when the positive half cycle comes from T2 to T3, again it repeats the case 1. It goes on. Here it will be off. So this is how you get the output of the half wave rectifier. Now coming on to the peak value. To find out the peak value, you know that input is a sinusoidal wave, right? Input is a sine wave. Yes or no? Input is a sine wave from the main. So what this transformer does, 240 volt is converted into 12 volt. Okay. Now here, what is the peak value? The peak value is given by the equation. The peak value, or I can tell that the peak value at the secondary winding. The peak value, I am going to find out the peak value at the secondary winding. Okay. So V in at secondary. So this will be your secondary winding. It is given by the formula Vp is equal to root 2 into V RMS. Okay. So what is your root 1.414 into V RMS is nothing but your root mean square value. It is equal to 12 volt, right? Now 1414 into 2, what you will be getting into 12. 4 2s are 8, 2, 4 2s are 8, 2, 1 4 4 1 4 1. So you will be getting 16.968, right? So approximately Vp will be equal to 16.968. I can approximate it to 17 volt. So here the peak value will be equal to 17 volt. Okay. Now for ideal case, the diode will conduct, this is for ideal case, the diode will conduct from 0 volt, we can say. But in practical case, for any diode, for practical case, if I take 1N4007, the diode breakdown voltage will be, the diode will start conducting at 0.7 volt. Okay. So for in the case of practical case, the conduction will start from 0.7. So what will be your Vp? Vp will be equal to 17 minus 0.7, which is equal to 16.3 volt. So when the 17 volt signal comes to the diode, towards the diode, the output of the diode will be 16.3 volt for practical case, because the diode will start conducting only after 0.7 volt. So the output will be, across the RL you will be getting the value of 16.3 volt. Okay. So this is the explanation of half wave rectifier. You have to draw two diagrams, case 1 and case 2. Now let's see about full wave rectifier. So let me draw the biphase rectifier once again. Right. So the overall diagram is, you will be having a center tapped transformer, right? The input is going to be 240 volt. So you will be utilizing two diodes, right? Diode D1, so it is center tapped, okay? And you will be using diode D2, okay? So diode D1 and D2 will be connected. Now center tapped, so this is going to be your load resistor RL. Here you will be getting your output V0, okay? So this is your diagram. So here if I take this as A, B, C, now what will be the voltage VAB? VAB is equal to 12 volt. Similarly, what will be the voltage VBC? VBC will also be equal to 12 volt, right? D1, D2. This is your overall diagram. Now, just similar to the half wave rectifier, the full wave rectifier will operate in two cycles, right? During the positive half cycle and during the negative half cycle. So if I take this as the input, V in T, V out. So you know that input is a sinusoidal signal, right? So we have to plot the output. This is going to be your output. So if I take this as 0, T1, T2, T3. Now we have again two cases. So let me consider case 1. So in the case of case 1, so the time is what? 0 to T1. Time period is 0 to T1. So what signal comes in? So during positive half cycle. So during positive half cycle, how will your circuit look like? The diode will act as a closed switch when it is forward bias. The diode will act as a open switch when it is reverse bias, right? So now during the positive half cycle, how will your circuit look like? So you have a transformer. Just reconfigure the. So I am leaving the space for diodes. Okay. It is acting as a switch, right? So the diode will be connected here, and you will be, since it is center tapped, you will be getting the resistor output across this RL. Okay. Now, during the positive half cycle, what will happen? So positive, negative. So this voltage is going to be 240 volt. Okay. So what will be the voltage here? Here it will be, if I take it as A, B, C, positive, negative. Here it will be positive, negative. So the voltage here will be 12 volt. Similarly, the voltage here also will be equal to 12 volt. Now see here carefully. Here during the positive half cycle, this side is positive, here it is negative, right? So the diode D1, during positive half cycle, when the positive comes here, it is forward biased. Diode D1 is forward biased, so it will act as a closed switch. Whereas here diode D2, here it is negative. The diode D2, here it is anode is there, right? So negative and positive, it is reverse bias. So here it is forward biased and here it is reverse bias. So it will act as a open switch. So the diode D1 is forward bias, diode D2 is reverse bias. So you have only one concept. So in this case, what is happening? Diode D1 on, D2 off. I can tell it in this way also. So you will be getting the output. Okay. So how is the conduction? It starts conducting like this, and here this will be your conduction path. Okay. Because here it is acting as an open switch. Okay. Clear? Now let us go to the case 2. Case 2. What is your case 2 time period? T1 to T2. T1 to T2. So what during this half cycle, which half cycle comes in? So during negative half cycle. So during negative half cycle, what happens to your circuit? The circuit will be reconfigured into, again I can redraw the circuit. So 240 volt, right? The transformer. Let me again give way for the two diodes. Center tapped. So this is going to be your circuit diagram. Now, during the negative half cycle, what happens here? It is negative, positive. What will happen to your A, B, C? So here it is going to be negative, positive. Here it is going to be negative, positive. Okay. So here it is 12 volt. Here it is again 12 volt. Okay. Now, during the negative, which diode conducts? Here it is negative. So the diode D1 will be a reverse bias in this case, right? So it will act as an open switch. Whereas here it is positive. So positive, positive, it will be forward bias. So it will act as a closed switch. So diode D2, diode D1. So in this case, diode D1 is reverse bias. So it will act as an open switch. Whereas the diode D2 is forward biased, so it will act as a closed switch. Okay, so how will be your conduction? The diode D2, the connection, let me show it by another color. So it starts conducting, flowing, the current starts flowing through this like this, and it closes the loop. Okay, so this will be your current flow. So during the negative half cycle also, you will be getting the output. So you will be getting the output. Again in time T2 to T3. So in this case, what will be the condition? D1 will be off, D2 will be on. Again T2 to T3, you will be having the repetition of the case 1. So this is how your output looks like in the case of biphase rectifier. Now let's move on to the last type, that is your bridge wave rectifier. Okay. So now let me draw the bridge rectifier circuit. So next is the bridge rectifier, right? Rectifier circuit. Let me draw it again. So here you have the major diagram. So what will be the voltage here? 240 volt. Okay. Secondary of the transformer. Center tap is avoided here. Okay. So this is going to be your nodes, positive, negative. This is how I draw. You can draw in your own way. Okay. So I am going to complete the loop here. RL, and here you get V0. Okay. So let me take this as D1, D2, that is the opposite diodes, D1, D2, D3, D4. So what will be the voltage here? The voltage here is equal to 12 volt, right? So this is your diagram. Now what about the waveform? As we have seen in the previous introduction, so the input wave will be your sinusoidal wave, V in, right? So this is going to be your input wave. What will be the output wave? Output wave is similar to that of your full wave rectifier. Means it conducts in both the half cycles, right? So this is going to be your V0. So you have two cases. Case 1, what is your case 1? If I take this as 0, T1, T2, T3, T4, then this will be 0 to T1, right? That is during positive half cycle of input wave. So during positive half cycle of the input wave, so this is going to be your case 1. So how your diagram will look like? The diagram will be replaced by, so this is going to be your 240 volt transformer, step down transformer. Okay. Now let me replace it by pencil. Draw it by pencil so that you will understand it properly. RL. This is your output voltage V0. So here you will be having diodes D1, D2, D3 and D4. Now which diodes will conduct and which diodes will not conduct, you have to find out. So during the positive half cycle, what will be your signal here? Here it will be positive, here it will be negative. If I take this as node A and node B, the positive here also, here it is 12 volt, right? 12 volt. Here it will be positive, here it will be negative. So towards the node A, you will be getting positive. Okay. Towards the node A, you will be getting positive. Here when there is positive, which diode will conduct? Now you have two diodes in this node, right? D1 and D4. See here carefully. If here it is positive, D1 is positive this side and D4 is negative. So which will be forward bias? Because positive and positive, D1 will be forward bias and D4 will be reverse bias. So D1 will act as a closed switch, whereas D4 will act as open switch. Okay. So D1 will be on, D4 will be off. Okay. So this is the first working of D1 and D4. Now what about the node B? Here you have negative. So when negative signal comes here, negative comes here, what about your diode D3? D3 and D4. D4 here it is positive. So when negative comes here, negative and positive reverse bias. D3 will be reverse bias. D2 will be negative negative forward bias. So D2 will be forward biased. So it acts as a closed switch and D3 will act as an open switch. So this will be off and D2 will be on. I hope that you would have understood this. Okay. Now if I can draw, I am repeating it once again. In this case, D1 and D2 will be forward biased, D3 and D4 will be reverse biased. So it will be in the off condition. Now what will be the current path? The current always flows from positive to negative, right? So if I start the loop from here, it flows through the A. Here you have a closed path. It travels through the RL. Again it finds the path here. It reaches here. Here you have open switch. So there is no path. It travels through D2 and it reaches the negative. So this is it completes the loop from positive to negative. So this is the direction of the current flow. Okay. Now what about the case 2? So when you have the case 2 is nothing but what T1 to T2, right? T1 to T2. That is during negative half cycle of input wave. So during negative half cycle of input wave, what will be a circuit working? Okay. Let me draw the circuit. So here you have input will be again 240 volt, transistor T1. So here it is going to be 12 volt. Okay. Now here you can draw the 4 diodes. Let me leave space here. So here you have D1, D2, D3 and D4. Okay. So here now it is connected to RL and here you have your V0 across your load resistor. Now let us take the next case, T1 to T2. T1 to T2, you are applying a negative signal. So what happens to your negative? When negative signal half cycle, here it will be negative, positive. Here it will be negative, positive, right? If it is node A, node B, this is for easy simplification I am doing. If negative comes to the node A, then which diode will be conducting, D1 or D4? See, D1 is positive here, D4 is negative. So negative, negative will be forward bias. So D4 will act as a forward bias. It will act as a closed switch, whereas D1 will be reverse bias. It will be acting as an open switch. So D1 will be off, D4 will be on. Similarly here in this towards this side you have positive. So when positive comes to the node B, which diode will be conducting? See, D3 has positive and D2 is negative. So D3 will be on or D3 will be forward biased. Okay. So it acts as a closed switch, whereas D2 will be reverse bias. It will be off or it acts as an open switch. So this is how your circuit looks like. Now can we see the direction of the current flow? So always the current flows from positive to negative. Now it starts flowing from positive to negative, right? So so it starts flowing through from positive through B, that is to D3. Again it comes back to RL. It sees the path. Here there is a path. It goes here. It sees for two sides. D3 is open, so it goes along D4 and it reaches the negative. So this will be your current flow. Okay. So hope you would have understood all these three types of rectifiers.